Take a good look at your surroundings. Chances are that you'll see some electronic devices, and chances are that these electronic devices run on binary code to function. Now, binary code is present in all electronic systems. However, there's one type of computer that does not use it, and these are quantum computers. And there's some of the most powerful computing technology that we have. And there's a good chance that it will revolutionize computing and modern technology as we know it. Hello, and welcome to Let's Talk About. I'm your host, the host. And today we'll be looking at quantum computing, how it works, what it can do, the things we have to look out for, and what it means for our future. Before we begin our deep dive into this subject, we first have to understand the complex field of quantum mechanics. Don't worry, I'll summarize it. According to a book titled Quantum Mechanics, Concepts and Applications, quantum mechanics is a field of study that focuses on things at the small scale, such as atoms. There are several different concepts in this field. However, we'll be focusing on the concept of superposition. Let's say you're in a game show and you were tasked with guessing the number on a box, which was behind a curtain. Fortunately, the number could either be 0 or 1. However, until you can see it, you can't be sure which number it is. So until then, the box's number is technically in a superposition between 0 and 1, which means it exists in two states at the same time. However, it stops doing magic things after it's observed or measured, which then it chooses one state to exist in. Now, this was a highly oversimplified explanation of superposition, but it should give you a good idea of what superposition is. Now, a question in your mind right now is probably, are there any examples of superposition in the real world instead of theoretical examples? That's a great question, and the answer is yes. If you've done high school chemistry before, you've probably learned that electrons orbit atoms in nice circular orbits. However, the diagrams you've learned in class are in fact incorrect. The reason why is yes, because of superposition. When atoms are being observed, it's hard to see the electrons around the nuclei since they're so small. So instead of knowing their precise location, they exist in an area around the nucleus of an atom. Now, while this is interesting and all, you probably have another question, which is, how do quantum mechanics interact with quantum computers? Another excellent question. And the answer is that instead of bits, which are used in binary code, it uses qubits. According to a book titled Quantum Computing Explained, binary code is the most basic type of code, with 0 representing off and 1 on, with each being bits. Qubits, on the other hand, have values between 0 and 1, as well as it being able to hold infinitely many values until observed. This allows the computer to be significantly faster and compute much more data than a conventional one. Now that we've gotten the basics of quantum computing down, let's talk about how we can use it. The ability to compute significantly faster than standard computers allows for a range of potential applications. The first thing that comes to mind is how it can benefit the field of AI and related algorithms. According to a research paper titled Machine Learning and Artificial Intelligence in the Quantum Domain, a review of recent progress, quantum computers can help with computation such as computing certain properties of partition functions, simulated annealing, solving semi-definite programs, and performing approximate optimization. These are all terms that say that it improves the processing speed of AI and machine learning algorithms. Since AI proves to be a very useful tool, using quantum computers To improve this already versatile technology will greatly advance our civilization and the technology we already have. For example, think about algorithms that could predict natural disasters with greater accuracy and speed. Think about how many lives could be saved. There's one other thing quantum computers can do, which is to increase our knowledge and understanding of the molecular world. As I mentioned earlier, electrons, for example, exist in an area around a nucleus rather than a single point. This is because we can't see where it is since it's so small. Therefore, it exists in a superposition around the nucleus. But what if we could use quantum computers to compute quantum models? According to an article titled Prospects of Quantum Computing for Molecular Sciences, quantum computers are useful since the electrons and nuclei in molecules occur on incredibly small scales. To accurately represent them, we need a quantum model to show and describe them. Even though quantum computers might seem like a magical new technology that'll help us in a lot of ways, there's one major thing we need to look out for. That is the fact that quantum computers could hurt our cybersecurity. When we send messages, that data is usually encrypted, which makes it safer and harder to access. This is done by using specific encryptions that are insanely hard for other people to guess. But you and the person you're talking to via your device or the software that you use to chat know about this encryption key. According to a research paper titled The Future of Cybersecurity in the Age of Quantum Computers pose a severe risk when it comes to our online safety because they'll make it easier for hackers to break encryptions amongst other things such as passwords. However, we could theoretically solve this problem by creating new cryptography types or even using quantum computers to help with our encryption. In essence, this type of computing is incredibly useful yet hazardous for us. We could represent proteins better to create better artificial proteins for medical and computational purposes. On the other hand, we could eliminate the idea of cybersecurity. If we want to have a better understanding of the future, let's look at two of the several startups and companies that are trying to revolutionize the quantum space. By the way, they're not sponsoring this episode in any way. I just thought that their work was interesting. One of the companies, IBM, is making quantum computing applications more mainstream via their platforms and its resource, Qiskit. It's a software for quantum computing, and a startup known as Q Control is improving the hardware of quantum computers in ways that significantly raise the accuracy and speed. For example, according to the company, their work can increase the accuracy of the computing 10,000-fold. This means that quantum computers will become faster and more accurate than they already are. In short, quantum computers can change the world significantly for the better, and at the same time, potentially for the worse. As with any technology, we need to learn how to manage it early on, or else we lose control over it. I hope you've enjoyed this week's episode and learned a little bit more about quantum computers. If you'd like to see more of our episodes, check out our website, which is linked in the description. If you have any questions, email us at letustalkabout@outlook.com. Keep on learning, and we hope to see you next week. This is your host, signing off.